Let us look at the preparations of aldehydes and ketones. So we've often learned alcohols change into aldehydes and then to an acid. So I'm taking the first preparation as alcohol on oxidation give aldehyde. So a controlled oxidation is done so that I don't reach the next step, which is the acid. So alcohol to aldehyde with any oxidizing agent, potassium dichromate I have taken here. So there are 2 carbon atoms here, so an aldehyde containing 2 carbon atoms. So primary alcohols, I have used the word, give you aldehydes. Secondary alcohols give you ketones. So the reaction is taking place at this point, removing the hydrogen and this oxygen form water, removing hydrogen from here and this oxygen forms water. The second one is dehydrogenation. Now dehydrogenation is a similar thing, but water will not be formed because I am only removing hydrogen. Same thing with copper at 573, alcohols change into aldehyde. Removing hydrogen is also a type of oxidation, so dehydrogenation takes place. So aldehydes, these secondary alcohols change into ketones. The next important one is dry distillation of calcium salts. Calcium salts means I am making a salt of calcium with an acid. Acid-base reaction gives you a salt. So supposing my acid is, say, acetic acid, and I take a base calcium hydroxide. I'll get a salt CH3COOCa plus water. So CH3COO whole twice Ca, because calcium's valency is 2 plus water. Had I taken the other one, say I had taken NaOH with this, that is acetic acid plus NaOH, acid and base, give you CH3COONa plus water. Here I have not written 2 because sodium's valency is 1. So acid-base reaction gives you a salt, and so calcium acetate is written as CH3COO whole twice Ca. Similarly, if I am writing calcium formate, I use formic acid and the base calcium hydroxide. So there are 3 salts I have written: calcium formate, calcium acetate, and a mixture of both of them. So when I take only calcium formate, which is the first one, the aldehyde formed is formaldehyde plus CaCO3. So learn from formate, formaldehyde and CaCO3. From acetate, acetone is formed, CH3CO, CH3's acetone plus CaCO3. When I take a mixture of both of them, then acetaldehyde is formed, CH3CHO plus CaCO3. Only difference here is that on balancing it gets 2 and 2. These reactions are extremely important in conversion somewhere, or maybe direct reaction is asked. So coming back to calcium formate, formaldehyde, calcium acetate gives you acetone. From the words only learn it. A mixture of both of them give you acetaldehyde. Common product in all of them is calcium carbonate. The next reaction is Rosamond's reduction. So Rosamond reduction takes place when acetyl chloride. Now acetyl chloride is a compound of an acid. Meaning, if I take CH3COOH as an acid and instead of OH, I am attaching here Cl. It becomes acetyl chloride, CH3COCl. When this reacts with hydrogen gas, in presence of palladium and barium sulfate, it gets reduced. So imagine that this was an acid, I am moving backward into an aldehyde. So changes into an aldehyde. Now it can further change into an alcohol also, because alcohol, aldehyde and acid we have learned. I am at acid, aldehyde, alcohol. But I am not moving till there because barium sulfate and sulfur, which are put in this reaction, poison the catalyst, and so it is a negative catalyst, poisons the catalyst and checks further reduction to alcohol. So only aldehyde is formed. Again, extremely important. Named reaction is asked almost every year. Next is Grignard's reagent. You know Grignard's reagent is CH3MgBr. I'm using hydrogen cyanide. Now there's a triple bond here. So likewise, this will become positive, this becomes negative. Nitrogen is more electronegative, pulling electrons towards itself. And magnesium, you know, is the positive part. So CH3 gets attached here, MgBr gets attached here. So HCCH3 double bond NMgBr, because triple bond has on addition changed into a double bond. On adding water, this molecule now divides in 3 parts. So the first one gets the oxygen from here. So HCH3, that is acetaldehyde, is being formed. This is CH3CHNO. And ammonia and MgOHBr. Second reaction I've done with CH3C triple bond C and the next cyanide. So again, similarly, the reaction will take place. Mg attaches here, CH3 attaches here. So first addition reaction containing a double bond. Now with water it divides like this, forming acetone, ammonia and MgOHBr. From alkynes, we have already done ozonolysis before. So with ozone, the reaction takes place at the place of the double bond. Think that a hut type structure is formed. So I've removed the double bond from here. I've removed the double bond from this place and attached 3 oxygen atoms here. On attaching 3 oxygen atoms, it becomes an ozonide. And in presence of zinc and water, this ozonide breaks into 2. So CH3CHO is first one. The other one is CH2O, which is HCO and H2O. Similarly, in this case, you will try yourself because you've done this before. Attach oxygen atoms here, removing the double bond. Divide the compound into 2 and you will get 2 compounds. One will be an acetone. The other will again be the same compound, HCHO. From alkynes also you have done this reaction before. A triple bond compound, that is an alkyne. If I write down Hg2 plus and H plus ions, it means hydration, and you are going to react with water. So water is HOH, on one side H, on one side OH. This gives you CH2 double bond CHOH, triple bond changing into double bond. Now when the double bond contains OH, it is unstable. So rearrangement takes place. H from here shifts here, making it CH3CHO. So acetaldehyde is formed. If I take a higher alkyne and react with water, which was HOH, I'll have to attach OH here according to Markovnikov's rule and H here. In this case, both of them contain same number of hydrogen atoms, so doesn't matter where you attach H, where you attach OH. Whereas in this case, OH has to come here because of Markovnikov's rule and H comes here. So this is the first compound formed. Again, it is unstable, so I've shifted this H here, making it acetone. So in the first case, acetaldehyde and then acetone is formed from alkynes.